Hi, so this tutorial is to go with the first lab for GIS problem solving. And the purpose of this exercise that you guys are going to be working on is figuring out how to make point data, and especially when you have a lot of point data, look like something more intuitive, easier to map than what you're seeing on the screen right now. And these are data that you're going to have the opportunity to play around with. I'm going to put a subset of these in the lab exercise. So these are fire data across the US, and one of the pieces of information in there is what caused the fire. So you can see a whole bunch of these different colors over here, like arson caused it, or it was caused by a campfire, or children were burning stuff down, or whatever it is. There are hundreds of thousands of fires across the US in this database. It's temporal too, so it goes from, it's about 20 years worth of fire data. So you really can't make heads or tails on here, right? If I asked you, well, where in the US do most of the arsons, are we more likely to see arson-based fires? You're not going to be able to tell me that the answer to that question based on what these data look like by just blur, like blobbing all of these point data on top of each other. So that is the purpose of this lab, is to try to figure out, okay, how can we digest these point data a little bit and display them in a way that's going to be a little bit more intuitive for people to understand. So off we go. Okay, so these are the data that you should have available to you to play around with for this exercise. So if you don't have your campus trees raw data handy, go download those from Moodle so that you've got them, and then you can follow along with me. So this is a comma separated value, a CSV file, and GIS usually doesn't have too much trouble reading those in. It's a table. So first thing we want to do anytime you have a table, before you try to do anything else like display data or whatever else, you want to open it and make sure it actually came in looking like you expected it to look like. You can open this CSV file in Excel if that's an easier way. Certainly for me, it's easier to see things in Excel than it is as a GIS table a lot of the times. This data set is one that folks from UMass, from the who are working with the Arboretum on campus, were nice enough to give me. It is not a super clean data set. There are some typos in it. There are some other issues, with the species listed in it, not all being trees, for example. But we're not going to worry about that right now. We're just going to sort of treat this as data that we can play around with. So this is a table. I can see that there are a lot of fields, a lot of columns, but ones that are worth paying attention to is that we have a genus and species and a common name. So, our white pine, for example, red maples, various other trees that are planted on the UMass campus. Some other information about those particular trees, some that have to do with arboriculture that I don't understand and we don't need to worry about right now. And okay, importantly, for our purposes of mapping these data, we have an X coordinate and a Y coordinate. So that means that we can make these data spatial, right? So if you do not sort of intuitively in your head know what the coordinate system should be, whether it's a projected or a geographic coordinate system, I want you to pause this video for a second and think about that a little bit. Should these data be projected in a projected coordinate system or displayed in a geographic coordinate system? So I'm going to go ahead and do that display XY now that we know that we've got an X coordinate and a Y coordinate in this table. And I'm working in ArcPro. You can work in ArcGIS Desktop. All of these things are basically the same. So I want my X field to be that X coordinate. I want my Y field to be that Y coordinate. And here's the question of the coordinate system. All right, so hopefully you recognize that these numbers are between negative 180 and 180 in the x direction, and between negative 90 and 90 in the y direction, and therefore saw that these are degrees, decimal degrees, designating latitude and longitude. And you remembered that anytime you have data that are in decimal degrees, that is always going to be a geographic coordinate system. And anytime you have data that don't look like decimal degrees, it is never going to be a geographic coordinate system. So these are decimal degrees. I also am familiar with these areas because these are UMass tree data and Western Massachusetts. I've seen these negative 72, 72 westing, and 42 northing. Strikes me as familiar because that's where I live. So geographic coordinate system, GIS has already suggested this for us just by happenstance, not because it has any knowledge, background knowledge of what these X and Y coordinates should be. The World Geodetic Survey 1984 datum is totally fine. Let's just go with that. You know, if we pick the wrong datum, our trees might move around by a couple of meters maybe, but it's not going to make too much difference in the larger scheme of things. So off we go, displaying these data as XY. Slowly getting there. All right, so let's get rid of this thing, and then we can see, okay, you know, I see Amherst here, so that's a good sign. Here's the UMass campus, and we've got a bunch of, I think, pretty ugly looking dot symbols on this map, right? Remember, displaying XY data, these are not actually, it's not a shapefile or a spatial file yet. We need to convert these to create an actual shapefile. So I like to do that with the kind of cheating way of doing this. And I don't know where I actually want to save this. I guess I can save it to my project geodatabase. So let's call this campus trees. And if I were paying more attention, then I would know where my own default geodatabase is located so that I could find that later on. Okay, so now we have an attribute table. It should have all that same information that the original table had associated with it. Oops, including, you know, the genus and species of those trees, the size of them, their condition when they were planted, and we no longer need the XY coordinates because we have them as spatial data. But now we have a shapefile associated with this. And we really don't need this anymore. So just for the sake of cleaning, I'm just going to get rid of these things that I'm no longer using. Okay, so we could, you know, change the symbology of this to try to make it a little nicer looking, I guess. Oof, ugly. Okay, now it just looks like a big black blob. I don't know that those really do make them look all that much nicer, right? They're generally, you know, we could try saying like, oh, let's do this by like the genus of tree or something like that. And there's going to be a lot of different tree genera in here. You know, that doesn't look very nice either. Even if I spend a bunch of time kind of cleaning this up or trying to make it look, you know, like you can, one thing that I really don't like are the black lines around things when I'm looking at a bunch of dots. So sometimes I'll just like say, okay, just make them all black dots with no outline, but I want a different color for each genus. So now let's see if that looks any nicer. Yeah, no, it doesn't look any nicer. It still looks like a whole bunch of dots on top of each other, right? Okay, so what I want us to think about then is let us digest this information a little bit. So one thing that we want to think about is, well, what would we want to know for the map of the UMass campus? regarding, the different trees that are around. So one thing that you might want to know is, well, for any given area on campus, how many trees are there? Can you just give me a count of the number of trees? So in order to do that, you need to first be able to define what that area of campus actually looks like, right? So instead of thinking of this as dots on a map, dots displayed on a map, instead I want us to think of this as counting up the number of dots within a spatial area. And if we're thinking about an area, then that has to be either a polygon or it has to be a pixel, right? So both of those have area in addition to location. So in some way, we need to take all of these dots and translate them into polygons or pixels. And I'm just going to focus on the one where it's translating them into polygons right now. So there is a lovely tool that we can look up that is called a fishnet, after the stocking, presumably. Create Fishnet is a really nice tool where a fishnet is basically a whole bunch of similarly sized polygon squares, or rectangles, I guess, within a geographic area that you define. So what I'm going to do is use this Create Fishnet tool to basically create a grid. So essentially a polygons that kind of look like pixels, so look like a square grid. And then we're going to use that information to count up within each of these grid cells how many trees there are. Okay, so some of these things are relatively simple, like what do we name our output file? That one's easy. Let's call it Fishnet for now. Some of these things are a little bit trickier. So first thing to notice is that remember when we brought in the XY data for the campus trees, they were in that geographic coordinate system, right? So you can see I've got my decimal degrees scrolling down at the bottom as I move around on my map. The challenge with decimal degrees, if you're trying to create a grid, is that your grid cells, your polygons, are not going to be the same length on both sides. They're not going to be square if you create cell sizes in decimal degrees, right? Because remember, a degree is an angular unit. If I take a step, 1 degree north in Massachusetts and a step 1 degree west in Massachusetts, I'm going to end up at those are two different lengths. One's going to be a much bigger step. They're both pretty big steps, but one's going to be much bigger than the other. So that's the challenge with geographic coordinate systems. So I think anytime that you want to display something where you want a gridded look to it, you should do it in a projected coordinate system so that your grid cells, your squares, are actually square in meters or whatever length you want to define. So easiest way to do that is let's change the display of our map so that we are, rather than in a geographic coordinate system, we are instead in Massachusetts State Plane, which I have luckily favorited here, but if it's not already in your favorites, you can find it under the state planes. Our meters is what we want. And then scroll down for a while until we get to Massachusetts, not the islands, but the mainlands, and off we go. Okay, this is still displaying in decimal degrees, so let's change that to so that we are seeing our units in meters associated with that Mass State Plane. So what the fishnet is asking you for is, where do you want to start your fishnet? Where's the upper left corner of where you want to start? And what size of polygon squares do you want? Do you want them a meter by a meter? Do you want them 10,000 meters by 10,000 meters? You get to choose. So your cell size and width are going to be relative to the coordinate system. In this case, we just chose Mass State Plane in meters. So whatever you type in here is going to be in meters. If you already, like we do in this case, have some spatial data, then you can change the template extent to be the same as the campus trees, and then GIS will fill this stuff in for you, which is pretty nice. So this is basically making it, you know, picking an upper left corner that is the edge of this thing. And so now the only thing that we need to do is to figure out, you know, like how big of a pixel do we want? So I'm going to go with 50 by 50. Once we do that, it like that defines how many rows and columns are going to be in there. So that's why those other two options disappeared. We don't need them anymore. I want polygons, not lines. And let's see if this works. Okay, so good. Now we have a grid. So hopefully you had some sort of expectation that this is the type of thing that it's going to look like. So this is just a grid of a bunch of different polygons. So we could, you know, symbolize this based on the ID number or something like that, which is gonna, let's see, can open the attribute table. Oh, ID is 0 in all of these cases, so that's why it's all showing up the same. We can't symbolize by FID, but we can if we do this in a second. But basically, you know, these are all the same. They should all, if you clicked on the, you know, identify tool or something like that, you would get the same size for all of these. They should all be 50 by 50. And the important thing in terms of creating a fishnet or any, you know, if you wanted to create a raster surface of your points by using the point density tool, which is another way to do this that we're not going to talk about, but it does exist. There's a point density tool. The important thing is to choose a cell size that we're aggregating to that contains a bunch of trees in this case. So we can kind of zoom in and look and see, yeah, okay, these cells, you know, some of them have a bunch of trees and some of them have, you know, 1 or 2 trees or something like that. That's, you know, there's no specific science to this. It's more just like, yeah, I want to aggregate these things in a way that, you know, is visually going to make some sense here. So what you don't want is to have a grid cell size so small that there's only 1 tree in every single one, because then you just end up with a polygon that is essentially the same as all of your points. Okay, so we are good steps along the way here. We have a gridded surface that we're going to create, that we're going to put data into from all of these different point trees that we have on campus. First thing that I like to do, because we're going to add data to the, or we're going to use the data for this from this fishnet. So this is an important part, but in the attribute table, you'll notice that there's an FID, right? So every single fishnet in here has a unique identifier labeled FID. The problem with the FID field, as you noticed when I was trying to symbolize it before, is that GIS doesn't always let you select FID. And also, every shapefile has something called FID, right? So if I open my campus trees, well, in this case, I have object ID, but lots of other ones will have something called FID or object ID or something ID in there that makes it confusing when you're combining different shapefiles and you have multiple FIDs coming from different shapefiles, because then it can be hard to keep track of, well, which FID does this one go to? So to avoid doing that, what I want to do is add a field to this that I'm going to call Fishnet ID. Long integer is totally fine because I just want numbers, basically like 0, 1, 2, 3, and the rest of it I'm not going to worry about too much. So now I should have a new field. And for this field, I want this field to just be unique identifiers. I'm going to clear the selection so that it operates on everything. And the easiest way to get a unique identifier in all of these is just to make it the same as FID, because this is a unique identifier, but it's hard to select sometimes. So let's make this the same. So I can do that with my field calculator, where all I say is my field Fishnet ID is equal to, oops. Oh wait, sorry. This is new to me. I'm used to ArcGIS Desktop. So this is already saying my field Fishnet ID is equal to, and I want it to be equal to FID. All right. Lots of other complicated things I could do there, but this is a very simple one. So I'm just copying this field into that field, basically. So now I have a whole bunch of unique numbers over here. Now I could do my symbology based on Fishnet ID and put all those, you know, unique 44, 88 symbols in there with all their different colors. That's probably asking a lot of GIS right now. So we should have a giant, crazy rainbow going on as soon as this finishes loading. Yep. It's a pastel, it's a magnificent pastel wall, or it's like the 70s or something like that. Okay, beautiful pastel wall. So I have a Fishnet ID. I have a whole bunch of trees. Now what I want to do is to count up the number of trees in each of these Fishnet IDs, right? So that is a tool that you guys should remember of either a spatial join or an intersect. Either of those two would work just fine. Spatial join happens to be in my fast access tools, so let's use that one. Okay, so what I want is for all of these different trees that I have, my 10,000 trees or whatever it is, I want to know which Fishnet ID is that tree located in. So my target features are my trees, and I'm going to join to them the Fishnet, and all of the rest of this is totally fine. Campus trees, maybe I'll just call it campus trees with Fishnet or something like that. Oops. So this should create the same exact shape file. It's not going to look any different. It's not going to be the same color. It's going to show up as a bunch of black dots or something like that. But in addition to all of those fields that we had before, it should additionally have the field of the Fishnet ID. All right, voila. So here is our new trees with Fishnet. That took a little while to run for me, maybe like a minute or something like that. When I open this attribute table, it should look exactly the same as it did before. So all the same fields, except when I scroll all the way over to the right, I should have these two new fields came from the Fishnet, right? So this is, there's no FID in this case that even got brought over. So that's why adding that unique Fishnet ID was really important. Okay, I'm just gonna sort this. So what this tells us is that Fishnet number 25 has 4 trees in it, right? Fishnet number 26 has 1 tree, 27, 28, all those presumably have 0 trees. You know, 81 has 2 trees, 82 has 4 trees, and so on if we went all the way down to the bottom. So now you need to remember, okay, well, that would take a really long time, right? If I wanted to go through and count up, you know, like how many rows there were for each of these unique numbers that's in the Fishnet ID. But you might remember that there are summary tools in here that can help you out here. So let us summarize. And the field that I want to summarize is going to be all the way at the end, my Fishnet ID. And in this case, what I want to do is to count. So, and count just means put together all the Fishnet IDs that are the same, like 25, and tell me, count how many there are. 4 in this case. So that should be relatively straightforward. This is going to give me a new table. So I will say, oops, maybe I'll call this count of trees. Evidently, I need underscores. Count trees. Count trees. I had to save it inside of the Geo database because it was, the format was not having it outside of it. Okay, so that should now give us count trees, right? This is a table. Let us open this table. Okay, so this tells us the information that we already kind of visualized or looked at in the last one, which is that Fishnet ID 25 has 4 items, 4 rows in it, 4 trees in this case. Number 26 has 1, number 81 had 2, number 82 had 4, and so on, except in this case, it did it for 980 fishnet cells, which contained at least 1 tree. So that's a lot faster than us doing any of that stuff by hand, right? Okay, now we know for each of these 980 fishnet IDs that have a tree in them, we know how many trees there are in each of those. So that's cool. And we have a fishnet ID, which you might remember is also in the fishnet. Go away. Which means that we can join it, right? So I've got information in my fishnet of the fishnet ID. I've got information in my count of trees with this fishnet ID, and I want to join the 2 together so that I can basically now visualize counts of trees based on, you know, how many trees there were in each of those fishnets. I don't know why this join is taking such a long time. Nothing's changed because we haven't visualized anything yet, but the one thing that should have changed is that we should have an additional piece of information over here, right? For most of these, because remember the fishnet is bigger than the trees, so we're gonna have zeros for a lot of these. But for some of them, we should have non-zero values. Those are probably gonna be down at the bottom, like these guys down here, right? So null in this case actually means 0, right? There are 0, well, there are 0 trees that the campus is counted anyway within that fishnet cell. And otherwise the numbers of count fishnet ID mean number of trees. You might be really good at remembering that count fishnet ID means the number of trees in that fishnet, but I'm going to forget that in like 5 seconds. So what I prefer to do is to say, let's change the field name to number of trees. Tree num trees. I can just change the alias to, and long integer is fine, short integer is fine. I only need numbers like up to 100 and something, right? Number, form of numeric, whatever, all of that is good. Okay, so I can say number of trees here, and there's my alias, and then we'll save those. And the reason I'm adding a new field is because you remember whenever you join something, it's only temporary, right? Unless I exported this file as a new file, that join will disappear as soon as I release the join. But this new field that I'm adding, this number of trees field, that is permanent and it's associated with the fishnet polygon shapefile. So that means that if I copy, just like we did with FID into Fishnet ID before, if I copy this count Fishnet ID into my new field number of trees, then I have saved that data within my polygon Fishnet. I had to pause for a second there while I yelled at GIS a little, and it amazingly did not crash, so that was a big plus. Okay, so number of trees, in this case, we're going to do that same thing. The field calculator, we're going to make number of trees the same as count fishnet ID. and that should just copy all of those values over. It may give you an error. It definitely does in ArcGIS Desktop that says, I'm going to convert all of these null values to zeros. But that's okay because you want them to be zeros. And hopefully when we scroll down to the bottom, we will see that these values that were larger values, like this 50 by 50 area with 164 trees in it, millions of tiny trees, have copied over correctly. So that's good. And now I don't need that join anymore. I don't like having all these extra fields going on. So yes, for real, remove the join. Okay, so no more extraneous join fields. We've just got numbers of trees. Presumably, now if we go to our Fishnet here, rather than symbolizing by Fishnet ID, which was just a random number, we can instead now symbolize by number of trees. And in this case, we probably don't want it to be unique values, but instead a graduated colors, right? Because we've got from low to high. So graduated color is a typical one to use in there. Number of trees, please. Okay, so I don't know if blue isn't really like a tree-y kind of color scheme. Let's see if we can get some green going on in here. All right, so now from what was originally, our blob of trees, we instead have a synthetic view of how many trees there are in this spot, and we can do this. I don't like the natural breaks, by quantile so that there's equal numbers in each of these different bins, or you can mess around with these values however much you want. But ultimately, for me at least, I think this is a lot more intuitive and a lot easier to kind of visualize and display than the giant blob of all of these campus trees. Okay, counting, relatively straightforward, right? So if I asked you instead to tell me how many maples, like tell me the count of all of the different maple trees on campus in each of these different blobs, how would you do that? So you can pause for a second to think about it. How I would do it is I would select all of the maple trees from my campus trees, export them as their own shapefile, and then repeat exactly what we just did with that process of doing the spatial join, summarizing them based on the Fishnet ID, joining that back to the Fishnet so that you can visualize in graduated colors. Here's another challenge. How about if I wanted to know the number of different trees that there were in each of these different Fishnet cells? So that is something that in ecology terms we would call richness, so species richness within any of these different ones. That is a little bit trickier, but fortunately, the summarize tool can help us out with that. So let's do that next step further of saying, not only do I want to know how many trees there are, I want to know how many different trees there are in each of these different blobs. So richness, or numbers of species of tree in each of these, I can think of a couple of different ways to do that. One way to do it is with the tool called, I think it's called delete identical. Let's see if we can find that. And what you can do with this is that we know with the trees, that shapefile that we created of the trees with the Fishnet, we can then select a couple of different fields where we want to like delete duplicates basically is what we'd be doing. So in this case, we would want to delete duplicates from the Fishnet ID as well as from the species or genus, depending on what we were doing. And what that should do is remove all of the rows where you have the same Fishnet ID and the same genus, because we don't want to double count those, right? So that's one way to do it. That creates a new shapefile. If you were using the raster tool to do this, the point density tool, then delete identical would be the way to go, because you only have like one numeric value. So basically the point density can only do a count. So, so this would be a good way to go. There's another way to do it though, which is using that summarize tool again. So let's once again, I don't care about the fishnet. I want to go back to my trees with the fishnet and open the attribute table of that. And in this case, so you're probably familiar with the summarize tool. You definitely are, because we just used it a second ago. But there's a larger tool which is now embedded into ArcPro called Summary Statistics. If you're using ArcGIS Desktop, then Summary Statistics, you have to actually look it up to find it. But the nice thing about Summary Statistics is that it allows us to summarize based on multiple fields. So previously we just did the summary based on this one single field of Fishnet, right? So we counted up that there were 4 25s and stuff like that. Summary Statistics allows us to also include a field of species, for example, or genus if we wanted to do richness at a genus level. All right, so let's get to our summarize. This is it's just a right click to get in there in ArcPro. And the way that we want to do this is by the case field. So it's automatically filling in genus, and I want to also do a case field of the Fishnet ID. So this is basically saying it's going to separate out every time that it has thuja, for example, and I'm doing this by genus rather than by species for reason being because there are more errors in the species one than in the genus one, but you could do whatever you wanted. So if we have, say, 4 thuja and they are all in Fishnet 25, then what I wanted to do is to look at both of those two things and find only the ones that are unique in there, right? So that would only count once, like 1 thuja and 1 Fishnet 25, I don't need to count the same thing 4 times, but I wanted to look at those 2 fields. And then because we're still doing a count, it doesn't really matter which of these we choose. It could be any field. Okay, so it makes more sense when you actually get to see the output table of this. So I didn't rename this as I output it, so we get trees with Fishnet ID, statistics 1. So the important piece here is that there should be a bunch of genus, so Acer, right, in this case, and a bunch of Fishnet IDs, and then these 2 things are going to be the same, which is basically the count of the number of Acers in 2478. There were 12. There were 2 Acers in 2479. This makes a little bit more sense if instead we sort based on Fishnet ID. So for example, there were in Fishnet ID 4 thujas, right? In number 26, there was 1 Acer. This one now is more interesting, right? So in Fishnet ID 82, there were 2 Acers and 2 betulas. So that actually means that the richness at a genus level in Fishnet 82 was 2, right? 2 rows. Whereas in this one, it's only 1 row, 1 row, 1 row, because there's only one of those genera in that fishnet. So remember, we've already done this in terms of counting numbers of different rows. And now we can count the numbers of different rows again, right? We just did a summarize, but now we care about the count of the unique fishnet IDs in this secondary output, because I want to know that there's one species or one genus in 25, one genus in 26, one in 81, but two in 82. So that's just another summarize. We're summarizing our summarizes. Maybe I'll name this something like more intelligent this time. So this is our genus richness. And in this case, I want my fishnet ID and I want to count up however many there are. Let's see if this works. It's very exciting. All right, opening up our genus richness, and now we have, now we see that I obviously had something selected. Let's try that again. I cleverly named it too. Genus rich 2. We just want to count. So let's try this one. All right, so now there was one row of 25, one row of 26, one of 81, and two, remember, because there was the Thuja and the Acer and Betula in 82, right? And so on down the field, down the column. Cool. So that is just kind of like a sneaky way to count up the different numbers of, in this case, genera within each of those fishnet cells. We want to get this back so that we can visualize it in the fishnet sense. We do exactly the same thing that we did before. I've got a fishnet ID, I've got account fishnet ID here, and I am just going to join that right back up to my, in this case, genus, fishnet ID, and I want this to be genus rich 2 with the fishnet ID, and okay, off we go. So let me open my fishnet table, and let's just double check. Okay, so we have this count fishnet ID. It should have a bunch of nulls in it, but it should also have some values in it, hopefully someplace down here. Let's see. Okay, it's got some values in it, so that's good. It's not all zeros, right? We do expect plenty of zeros because of all those places where there are no trees. Once again, count fishnet ID or frequency, not particularly illustrative of what's actually going on here. So let us instead name this number of genera, and I will call this number of tree genera. Good. And then I'm going to use my field calculator to get that over here, which is my count of the fishnet ID, blah, blah. And then once we're done with this, we can remove the join again so I don't have to deal with all of that stuff. Great. Okay, and then here we are back at our symbology where I am using, let's see, my fishnet with graduated colors. And in this case, rather than number of trees, I instead want to do number of genera. And let's turn that guy on. And go away. How do I get rid of this thing? My goodness, do I have to close all of these? I don't even know where the X is. Do you have to close them all individually? I'm new at ArcPro. I'll close them all individually. It's annoying. Great. So here was my colors with the number of tree genera. There it is with number of trees. You know, I don't know, if you put these side by side, get them in a couple of side-by-side maps and look at them, then you might see where the differences are. But, you know, places with a lot of trees apparently on the UMass campus also have a lot of different genera of trees. So hopefully that was helpful in terms of thinking about a visualization. If you want to try a new tool, try out that point density tool, which is one where it takes all of the point data and turns it into a raster grid rather than a fishnet of polygons. And your lab exercise should take this, basically give you more practice doing this with a new data set. So enjoy.